In the previous video, we introduced the overall positioning of Phalcon Security and its core capabilities in risk monitoring, attack blocking, and ease of use. Now we'll walk through the platform step by step, following a real-world workflow. Alright, let's not waste any time. Let's jump straight into the Phalcon product interface. Okay, what you're looking at now is the Phalcon Security product interface. When you first land here, you'll see that the dashboard includes an onboarding guide. Step 1 is to import the contract addresses you want to monitor. Step 2 is to review the monitoring rules we've automatically matched based on the contract addresses you imported. These are what we call monitors. If those aren't enough, you can also create new monitors yourself. Step 3 is to bind the appropriate emergency response measures to your high-risk attack monitoring rules. These response measures are what we call actions. Step 4 is to set up your notification channels. For example, if alerts are triggered, checking them only through the platform is obviously not convenient or timely enough. So you can push them to the collaboration tools your team already uses, or a messaging app. For example, we support Slack, Lark, Telegram, and more. That's the onboarding flow. Below that, you'll see alert activity, things like trigger counts and distribution. Now let's walk through each step in detail. First up, import the contract addresses you want to monitor. We currently support single address import, import by protocol name, and bulk CSV import. I've prepared a balancer contract, specifically a wallet contract address. Let's enter this address. Okay, we can see this wallet address exists across 12 chains. The majority of the TVL is concentrated on Ethereum and Arbitrum. Let's say we only select one of them and import it. Okay, it's showing that one attack monitoring monitor has been automatically matched. After importing, we can see in the addresses list this address has appeared, and a monitor has already been matched to it. Let's go into the details page to see what this monitor is and what type it is. First, it's an attack monitoring rule. Its severity level is critical risk. The contract it monitors and protects. If you hover over here, you can see the specific contract address. And if an attack occurs and the estimated loss exceeds $50,000, we classify it as an attack. That's the specific rule for this attack monitor. Beyond that, BlockSec supports many other types of monitoring rules. Let's go through them one by one. Click Create Monitor, and you'll see all kinds of monitoring rule templates. What we just demoed was the attack monitoring template. In addition to attack monitoring, we also support operational risk monitoring, interaction risk monitoring, financial risk monitoring, safe wallet monitoring, and custom monitoring. Let me quickly walk you through each one. For example, operational risk. What does that mean? Your smart contract should normally be upgraded only when the core team is aware of it. But if suddenly a smart contract upgrade happens that nobody knows about, it usually means one thing. Some of our privileged private keys may have been compromised. That's something we need to take seriously. So we've designed two monitors related to contract upgrades. The first fires when a contract is upgraded, so you can verify whether it was expected. The second detects when, after an upgrade, a version incompatibility appears. This could be caused by a developer mistake, but that kind of mistake could also be exploited by attackers down the road. The platform needs to catch that too. In addition to those two, Oracle monitoring is also critically important. We've seen a huge number of on-chain attacks caused by Oracle price manipulation. For the oracles we're monitoring, we check whether a price deviation has occurred, whether it's gone outside the expected price range, whether there's a significant divergence from major Oracle prices, and so on. We also check for price update delays or heartbeat delays, and more. All of that falls under Oracle monitoring. Third is interaction risk. For example, many attackers gather funds before launching an attack. The sources they use to do that are usually not particularly clean. For instance, they might fund themselves through Tornado Cash, or use tainted, high-risk addresses as a funding source. And of course, flash loans are also commonly used, whether for arbitrage or as a way to fund an attack. The second area is whether, after a transaction occurs, it causes a significant drop in a token's price or a sharp decline in a token's balance. All of these are considered financial risk. The Safe Wallet Monitor is primarily designed to address the "what you see is what you sign" problem. The Bybit $1.5 billion attack was exactly this issue. The transaction the signers approved on the safe front end didn't match what actually executed on-chain. So, how do we use a simple approach to clearly communicate to each signer of the safe multisig, including finance team members, C-level staff, and operations staff, and help them easily understand each transaction on the wallet and what it actually does, and whether it triggers any high-risk rules? All of that is monitored through the Safe Wallet Monitor. Custom Monitor offers even more flexibility. This is particularly suited for teams that have security personnel who want finer-grained control over their monitoring dimensions. They can use this component to build rules like assembling Lego bricks. The first step is to filter transactions. By default, all transactions pass through our attack detection engine. If you only want to focus on transactions we've flagged as attacks or suspicious activity for further monitoring, you can filter and narrow the scope here. Step 2 is to select the wallet or contract address you want to monitor. Right here, you can see that we support 5 types of monitoring rules. The first is token balance. Here, you can see all the tokens held in your contract, along with their balances, which we've already identified for you. You can make multiple selections here. And below, using an expression like this, you define the rule. You can also stack additional rules on top of it, for example, token price, which works very similarly. If you're dealing with a contract that involves a token pair, you can select the corresponding pair here. This one is key variables. For key variables, you'll see the storage layout, which we've already pre-populated for you. We've also resolved it for you, so all you need to do is check off the variables you want to monitor, and then write your rule here using an expression. Write the rule, and you're done with key variables monitoring. We also support sensitive events. As you can see here, you can select the event you want to monitor. This option ignores the event's parameters, or you can use the parameters for more fine-grained monitoring. There's also an expression field here for further customization. And this is function invocation. Similarly, you can select the specific function and choose whether to ignore parameters, and so on. That covers how to configure a custom monitoring rule. Once you've selected everything and finished setting up all your monitors, you'll also need to configure actions and notification channels. For actions, we recommend binding actions only to critical risk monitors. For medium and low risk monitors, being notified is sufficient. You just need to be aware. In that case, you only need to configure a notification channel. Here, you can configure an action. Since I don't have an existing action in my account, I'll create a new one here. When creating one, you'll see we offer 3 modes. The first is pre-signed transaction. You pre-sign a transaction for us, and we automatically calculate the nonce. Then, when an attack occurs and this monitor is triggered, we can fire the action with one click. The second mode is delegating to us. This is a single SIG delegation approach. And the third is multi-SIG delegation. For example, if your pause contract transaction requires a multi-SIG, then you'll need to use the multi-SIG with delegation approach. One thing to note, actions are chain-specific, but sometimes, say we detect an attack on Ethereum, but the contract itself is deployed on multiple chains, not only on Ethereum, but also on Base and Arbitrum. And you want to kill the switch across all chains at once. How do you do that? You can bind multiple actions to the same monitor. In other words, the relationship between a monitor and its actions is one-to-many. Specifically, here's an example. Say we detect that Ethereum's wallet contract is under attack. That monitor can have multiple actions bound to it. Action 1 pauses the protocol on Ethereum. Action 2 pauses the protocol on Arbitrum. And Action 3 pauses the protocol on Base. If this monitor has all 3 actions bound to it, when the monitor fires, all 3 actions fire simultaneously. That means an attack detected on Ethereum triggers attack blocking across multiple EVM-compatible chains simultaneously. Finally, there's notification channels configuration. I've already set up some notification channels here. The BlockSec platform currently supports multiple notification methods, such as Telegram, email, webhook, Slack, and more. What does a triggered alert look like? Let's look at two examples. The first is a back-tested attack transaction. You can see this is on Arbitrum, an attack transaction targeting Pendle. Let's click in. We're now in the alert detail page. Here you can see the description of this alert, identifying an attack transaction, the hash of that attack transaction, and the fact that it caused close to $680,000 in losses. The detection stage is on-chain. The other possible stage is mempool. Because this attack transaction occurred on the Arbitrum chain, which has no mempool, the earliest point we can detect it is on-chain. That's the earliest possible stage. You'll also see the from/to addresses and the attack transaction hash. Next, there's the investigation module. Here you can see, for this attack transaction, how each step played out. Reading from top to bottom, first, on September 3rd, 2024, the attacker obtained funds via Tornado Cash. On September 4th, the very next day, they deployed an attack contract. You can see the corresponding transaction. Then, just a few minutes later, they launched the attack transaction. At the same moment, you can see they share the exact same timestamp. The rest follows the same pattern. Phalcon detected this attack. That's the full sequence of the attack. Which wallet addresses were affected and had their balances changed by this attack? There's a very detailed balance change view here. If you're a Phalcon Explorer user, this page will look very familiar. It's the same as Phalcon Explorer. We show all the addresses affected by this transaction, the affected addresses, their tokens, token balances, and the corresponding USD value at that exact moment. We also show the corresponding fund flow. That's what an alert detail looks like after an attack monitor fires. Now let's look at another type of alert that a lot of people care about, the safe wallet alert. This one is a backtest of the Bybit safe wallet attack transaction. The Safe Wallet Monitor, in simple terms, identifies each on-chain action as it actually happens, decodes it, and tells your operations team and C-level what each transaction and each action specifically involves and what risks are present. Specifically, in this transaction, you can see we identified 3 risks, 2 operational risks and 1 interaction risk. For the 2 operational risks, the first, we detected that your wallet is being upgraded to a new contract address. The details are available here. And the second, your wallet is interacting with an unverified address using a delegate call. Both of these are considered rare and high-risk situations. Safe wallet transactions are normally transfer transactions. Using a method like this is extremely unusual. So we flag this as a high-risk behavior. Then there's also the interaction risk. This transaction was initiated by a suspicious address. What makes this address suspicious? We identified that this suspicious address is not one of our signers, and its very first transaction was with our wallet. That is clearly a very suspicious address. Here you can see from the moment this transaction is created, through each person confirming it, to it being confirmed on-chain, we check every step of the way. And as soon as high-risk behavior is detected, we send an alert. So if such a high-risk alert fires multiple times and we do nothing, that's just not realistic. These risk behaviors are very unlikely to be missed. Through this cross-check approach, we can ensure that the transaction signed on-chain matches the transaction that we actually reviewed and intended to sign. It's the same transaction. Likewise, we also show balance change and fund flow, and so on. But because this attacker's transaction is fundamentally a contract upgrade transaction, not the transfer transaction the signers believed they were signing, it inherently has no fund flow changes. Beyond these core features, we also have a test kit feature. Basically, once your monitor and actions are all configured, you definitely don't want to sit around waiting for a real attack to happen in the wild just to find out whether everything works. Whether the configuration is correct. We want to be able to run a quick test beforehand. We support 2 testing modes. One is using a real historical transaction to run the test, to see if it triggers the corresponding monitor and action. The other is by constructing a simulated transaction to run the test. Both test modes run in our test environment. They won't affect anything on mainnet. That covers the core features of BlockSec's Phalcon Security product. Finally, a quick note. BlockSec's Phalcon Security product is currently invite-only. You'll need to book a demo and receive an invitation to register. So if you're interested in what we've shown here, feel free to visit our website and book a demo. You can also register directly on our platform, which gives you access to another product, the one we mentioned earlier, our crypto AML product, Phalcon Compliance. A demo of that product will be covered in a separate chapter. Okay, thanks everyone.